Hello, today we're going to be talking about adding fractions with unlike denominators, but we're going to start with same denominators. First good step is to estimate. A little less than half plus about half is going to be about 1, but maybe a little less. So 3/8 plus 4/8. The eighths is just talking about how big the pieces are, and there are 3 of them, plus 4 more is 7. So that's 7/8. You can just count up the pieces if they're the same size. And that denominator on the bottom, if it's equal denominators, then you know that you have the same size pieces. Same size pieces can be added together. And that's a really important idea to remember when you're adding fractions. We're about to add fractions with different denominators, but I'm going to choose the first example to be exactly the same as 3/8 plus 4/8, but I'm going to write it with a different name. 3/8 plus 1/2. 1/2 can be written with the same size piece as 3/8. 3/8, eighths are small. Halves can be arranged as eighths as well. You can use the multiplier rule and find that 4/8 is the same as 1/2. So 3/8 plus 4/8, again, without a visual, can still be done by finding the same size piece and adding them up. Here's another example. We have 1/8 plus 1/2. I'm estimating it's going to be a little more than a half because 1/8 is almost 0 and 1/2 is bigger. Now, if we split these into eighths, we know halves can be split into eighths, 4/8. We can do the math. 1/8 plus 4/8 is 5/8. How about an example without just halves and eighths? What if you had 3 fractions that all had different denominators? Now the piece sizes are half, fourths, and eighths. I've chosen some that can be split in the same size piece, and eighths is the magic number here because halves and fourths can be split into eighths. A half can be 4/8. You can use a multiplier rule if you like. 3/4 can be written as eighths. 6/8. And 3/8 is already eighths. When we add these up, the equivalent 4/8 for 1/2 and 6/8 for 3/4 and 3/8, we get 4 plus 6 plus 3, 13/8. Now, 13/8 really should be written in a simpler way to understand as a mixed number. One way to think about this is that if you have 13/8, you still have the same size piece, eighths. You have 13 of them. So you have 1 whole and then 5/8 left over. A good way to think about that is that 8/8 for a whole plus 5 more is what 13/8 is. Let's see one example that doesn't have to do with halves, fourths, and eighths. We'll do halves, thirds, and sixths. Oh boy, if I'm subtracting stuff away, I think we might end up with something close to nothing. Sixths can be used to describe all these pieces. 1/2 is the same as 3/6. You can use a multiplier rule, but you can also do a drawing that splits it up. 1/3 can be written as 6. One way to know that is that 3 is a factor of 6. If 3 is a factor of 6, we know we can make equivalent fractions in sixths. Once we've made our equivalent fractions, 3/6, 2/6, and 1/6, they have the same size piece, and so we can add them up. 3 plus 2 is 5. Oh, we're subtracting. Oh my gosh! When we take 2 away from 3 and 1 away, we're getting 0/6. Thank you very much. I do want you to remember that finding equal denominators, finding equal denominators is like finding the same size piece. And in this case, you need to find the same size piece to really do the adding. Or you know what, the adding and subtracting. You know what, we've done enough today. Thank you.